In this first example, we will be discussing linear momentum, which is basically mass and velocity put together. As you can see, we have absolutely no momentum whatsoever, because we have no velocity. However, if we do apply some velocity, we will eventually gain momentum. And the faster you go, the more momentum you have. And while discussing momentum, we also must discuss the conservation of linear momentum. And when we mean a momentum is conserved, we basically mean that there is an opposite force trying to oppose the direction we are going in. However, if we continue to apply the same momentum in one direction, the opposite momentum will equal it, thus keeping the momentum conserved because it doesn't change whatsoever. However, if we are to, say, release the gas pedal on a car, we would slowly stop because of another force called friction, basically leaving us with no momentum at the very end. However, this is still a gradual process, which means it will take a little time for it to happen. Here is one example of large momentum. See this gigantic tugboat? Even though it's really big and very slow, it still contains large momentum, because momentum is a factor of both mass and velocity, or speed and direction. So even though it's moving at a really slow rate, it still contains high mass, thus giving it large momentum. To demonstrate another example of large momentum, I'm going to shoot this unsuspecting green house many times. As you can see, the bullets move incredibly fast, but they have really small mass. However, since because of that equation, we still have large momentum. Don't worry, these bullets are not real. They're only rubber. Here we go. We're going to explain how to change one's momentum. The best example, I think, is to use parachuting. First, we are going to show an example of impulse, which is basically the time it takes to change the momentum versus the actual force of momentum itself. Impulse is a great factor in parachuting, and we will witness this right now as Jacob is going to show an example of what one should do when parachuting to give a good example of impulse. As you can see, instead of crashing into the ground and imminent death, we slowly descend and safely land on the building in front of us. Now we're going to show you an example of what happens when you do not deploy your parachute and unfortunately fall to an untimely death. So, all you need to do, and it's very simple, just jump off the side of a building. And we'll just follow Jacob's example with that purple smoke and splat. As you witnessed right there, we both collided with the ground at such tremendous force. However, because of impulse with a parachute, that doesn't happen, thus giving parachutists a good and safe landing. Okay, to demonstrate the effects of impulse, we're going to play catch with an egg. So, here we have Jacob standing right over there, and I'm going to throw this egg at him. Hopefully, because of impulse, the egg will not break when I throw this at him if he catches it. Catch! Okay, that didn't work at all. Where'd the egg go anyway? The egg has disappeared. Fantastic, we just failed this physics on your own. Hooray! Alright, well the first time didn't work, so let's try this again. Jacob, are you ready to catch it? Alright, here we go. Ready? On 3. Try and catch this time. 1, 2, 3. Well, catching it with your face is close enough. Unfortunately, it broke. So, if this was real life, you could probably catch it by increasing the amount of time it takes for the egg to land on your hand. So all you have to do is just slowly descend your hands in order to catch the egg, in order for it to work. Well, that's how that works. Alright, the next example we're going to show is collisions. First, what you must do is build up speed. If you haven't guessed, we're going to collide with another person head-on. Namely, this will be Jacob. So what you must do, gain a lot of speed, then crash! And obviously, the man with the bigger vehicle wins. In this case, it was a bus. In this next example of collisions, we're going to try a bus-on-bus collision. Who do you think will win this one? Well, since they both have the same mass, and hopefully the same velocity, we can determine that they might hit about equally, but because of certain factors, we kind of just phase through each other and end up like nothing happened. Well, one day, me and Killian were out in Times Square, and we just noticed that there was a big pile-up accident that occurred in the middle of Times Square. Yeah. We might have a few ideas of what happened. Some of them may be silly, but I think this would be the best interpretation of what actually occurred. Boom, boom, boom. Boom, boom. Boom! Boom, boom. Boom. Boom, boom. Yay. So the next section talks about airplanes. Yeah, airplanes. Well, we found one. And you want to know something special about this airplane? It will never take off. No matter how long you follow it, it will never take off, nor does it increase speed. So yeah, there's your airplane. Another form of momentum that is commonly seen today is angular momentum, which is basically momentum on a point, orbiting around a point. As you can see, this example of a helicopter, the propeller blades are rotating about a point, being the middle, and, as we all know, helicopters use this in order to move up and down and left and right and so forth. So Jacob is going to show an example of it slowly lifting above the ground, hovering for a few feet, and then coming back down safely. Ta-da. And so this also applies with the conservation of angular momentum. As soon as Jacob sets out of the vehicle and turns off the helicopter, the propeller blades are still going to continue moving in the same direction, because momentum still needs to slow it down based on inertia and friction and all those other forces acting upon it. And as it slowly comes to a stop, and that is angular momentum.